In this lecture, we will see the weather station object classes. So basically, in order to understand the object classes, we need to understand it before this one, because if we are unable to understand that how the objects are placed and how can we set their functions. So before this, we need to understand the description of the object classes. So it's like some sort of the description that we receive from customers. So in that particular type of how can we draw the object classes in this lab session, we need to know the description. So a weather station is a package of software controlled instruments which collects data. As we have seen in the previous, so we have designed that how we have to collect the data. So we receive the data, then we transmit the data. So it was a little bit of module. So those were the function. But from the implementation point of view, how we have to develop a software. So in that fashion, perform some data processing and transmit this data for further processing. As I have told you that we receive some sort of the data, then we have to transmit that data. We need some equipments, some methodologies, some softwares, some hardwares, in terms of the media as well. So connectivity should also be there. The instrument include air and ground thermometers and anemometer, wind vane, barometer, and rain gauge. Data collected periodically. So as we know that if we continuously receive the data, what happens? A huge burden will be borne by the database. That's why there should be a period after the 5 minutes, after the 10 minutes, after means there should be an interval for data collection. So in algorithm, we need to define that thing in the particular thing that we can also predict. Data residuals should be there. So that's why rain is forecasted, wind is can be forecasted. Now every variable can be forecasted. What is the station number? What it is giving us the value, and what the neighbor weather station has given us the report. So based upon that, we have to see the variation, and we can think about the climate change also. So if we have last 5 to 20 years data, 50 years go back, we have the data. We can do a lot of research upon that, and we can think about the projects as well, because cleanness of the data is one of the dimension, and wind direction of the data is one of the dimension. So ground realities by ground thermometers, what is the temperature at the ground and what is in the air. We can have a research about this particular type of the data. So rain gauge is there. How much rain was? Sorry, the uh, Python spider has been opened due to the wrong clicks. Okay, so I have closed it. So when a command is used to transmit the weather data, the weather station processes and summarizes collected data. Then summarized data is transmitted to the mapping computer when the request is received. Now, in this, I will add one thing. that ontological research, mapping research, schema mapping especially, because there are variety of instruments. 50 years back, the companies have developed different instruments for weather, but now different modern IoT based equipments are with us. Even they have the capability of automated transmission as well. You can think about the projects as well. You can think about your latest technology can be used for these facilities. For example, cell phone is with you. Cell phone can also be used, can also be connected in order to collect the data like these things. But one thing, when we talk about the big data, actually the weather data is a big data because across the world there are trillions of weather stations. If they give us periodically after the 30 minutes residual, you don't think how much data can be generated by the weather stations. Lots of data will be there. If there is a data, you can conduct a research, you can develop a project. If there is no data, you can't. So this is from the research point of view and from project's point of view. But what we have to think about this before. So it was a description that was a mandatory that we have to receive there, and we could understand that how can we develop the object class for that particular. For example, object class identification in the weather station system may be based upon the tangible hardware. Tangible hardware means one is intangible, whom we cannot carry with us. Tangible means we can carry with us. So just like a mobile cell phone we can carry it, but we have the mainframe computer, we cannot move it around 24 hours with us. Data in the system, but data is a tangible. Yes, we can call it anytime. Now we have to see the object class identification weather station system may be based on the tangible hardware in the data in the system. It may be the case. So ground thermometer, anemometer, barometer, and the application domain objects that are hardware objects and related to the instrument in the system have the most prominent paradigm that we can use. And the weather station is a basic interface of the weather station is its environment. Of course, there is no doubt, and it therefore reflects the interaction of identified in the use case model, as we have seen that there is weather information, what are its responsibilities, then it's a control mechanism, and how can we control it, and then the weather data encapsulates the summarized data from the instruments. Now, how we will present in the class diagram. See, there is a weather station, then identifier, then reports, then report status, then the power save instruments, then the remote control instruments, then restart, shutdown. All these things are there. And number second, the weather data is there. In that, these are the temperatures, ground temperatures, wind speeds, wind directions, pressures, rainfall. Collect and summarize. These are the functions. So in the ground thermometer, what software do get identification, temperature, gate, and test. And same, these are the function of the barometers. Now, how we will draw into the EDRAW, in draw max. So Open your eTormax, and after opening eTormax, you can see uh, now what would be the guess you that what you will select. Definitely software, and then loss objects, where the results go there, click them just, and you will find out the way. So in this way, we have to think about that. We have to design. I will design this picture and one from this picture. Possibly I will draw a little bit. I will best, and you have to give this type of uh, the proper naming. And see your use cases that you have discussed in the class. And while discussing, you can see that how to tackle them. So in that particular way, now this is ready. Go for the new, create, and definitely I will go into the software and go yes class diagrams. I have clicked. I have bring this one clearly written whatever we want. Yes. For example, what we have to do, weather station, then identifier means I have to write down the class name, that is weather the station, and then the identifier of that particular weather station. Then what are the options are going down? See in previous slide, report weather. I'm saying that this is the report weather by calling some sort of the functions, making it more delightful, making it up, making it up. That number second, what was there? See the report status. Also, this is a function. If this is a function, then we have to give. Now you can write down where you want to lie. So picking it up, now whatever the thing we are picking it up, and then another. This is there. Little bit up into the same hierarchy. Now weather data, air temperature. Now see, this is weather data, and what we have the air temperature and many more. So I'm not going to show you. You have to type down yourself. So what is another? Collect and summarize. These are two functions. Collect and summarize. So these are two functions that are available. And then what we have to do that this is the ground manometer and barometer. I'm going to draw the one. So how many rows there? See, there are also three. It means same thing we have to collect. So what is this? This is the ground thermometer. Write down ground thermometer. And what are the other sources? Gate ID temperature, gate ID, and another is temperature, and another is gate test. So get its function and test its also function. So this is before you, and if you can take another one, and same like you can take another one. Now see, if you write down, put these text appropriately, this thing has been done quite mostly and quite easily because these softwares gives us some sort of the facilities, built-in facilities. Otherwise, we don't know what is the unified thing. Unifiedly, you can write down these things. So thank you very much for your active listening. Hopefully, this will be very much beneficial for you while you are working, especially